Okay, this is the second part. We'll continue solving some problems. PDF is given, piecewise 1, 2x over 15 within this interval, 5 minus x over 5 within the other interval, and equal to 0 otherwise. What they want the mean, I think, and variance. Anyway, since it's defined in two different places, then we need to treat them individually. Like we need to perform two integrals instead of one integral. So starting with the formula to calculate the expectation value or the mean, then we need to care about these two intervals individually. So the mean equals to integral from 0 to 3, that's the first one, and the PDF equal to x over 15, but we need to multiply it by this x, so we get x squared in here. And the second piece is the same, integrate from 3 to 5, and we multiply 5 minus x over 5 multiplied by x, so we'll get 5x minus x squared divided by 5. This is an easy integral. Power rule, integrating x squared is going to give me x cubed. Integrating x is going to give x squared. X squared is going to give x cubed. Taking care of these limits, substitute, and we are going to end up with this number. You need to check it. Like what you need to do is to hide these and then do it by yourself and see if you are going to end up with this number or not. Another PDF defined in two zones, two different intervals, and I think we need to find the mean also. Actually, this is the same. Sorry, this is the same one. Just part B, we need to find the variance. Find the variance or to perform. Also, we need to perform two integrals. Variance, integrate the function itself multiplied by x squared, and then we need to subtract the mean squared from the result. Our integral in here is going to be two different integrals because the function is defined differently into different zones. So plug in our value, the variance equal integrate from 0 to 3. The function is 2x over 15 multiplied by x squared, so we get 215 x cubed. In here also 5 minus x multiplied by x squared, we'll get 5x squared minus x cubed. And don't forget to subtract mu squared from your integrals. Again, this is the same, like integrating x cubed, you get x to 4, integrating x squared, x cubed, integrating x to 3, you get x to 4, caring about these denominator and your limits. Yeah, double check them. We are going, and then we subtract this, we are going to end up with these values. Now, how to calculate the mod? Definition of the mod is the maximum repeated value. Is the value of the like random variable where it's the most dense. Most dense, it means most repeated one. Calculus-wise is a turning point, the maximum point. How to find the maximum point in calculus? We derive and we set the derivative to 0, and then we find the variable x. The variable x, we are going to find it represents the mod itself. We'll see in this example. PDF is given two PDFs. They are independent. Like this one is not related to this at all. I don't know why they put them together, but yeah, you could focus on one of them. And so this one is given, and the question is find the mod. How to find the mod? We need to differentiate this function with respect to x and set the derivative to 0. How to sketch this function? I already talked about function like that, x cubed, and the root is given. You could sketch it easily. And then roughly we could see that the mod is something in here, like between 0 and 1, but it's closer to 1. That's from the sketch, but we need to calculate. How to calculate? Differentiate the PDF and set it to 0. We set it to 0 because the slope of the function at that point is excuse me, is 0. And then we solve for x. Here we find two values of x, either x equals to 0, and here doesn't make any sense. We are going to ignore this value. Otherwise, x equal to something between 0 and 1. That's the value we are interested in. Second PDF, as I said, it's not related to the first one at all. This is a straight line. So it's defined between 0 and 1. And what is the mod? The mod is the highest point. That's the highest point. Highest point when the function equals to 2. So this is equals to 1. Then the mod equals to 1. Almost we're done with the a PDF. Now to calculate the median is a specific case of quartile. This is the general word because Q2 is median, Q1, Q3, Q whatever. We are going to calculate any percentage of a median they ask about. How to calculate that? If PDF is given, we need to integrate it without limit to get capital F of x. What's capital of F of x? It's CDF, cumulative density function. What's so special in this function? This function represents area under the curve, and the maximum value of it is 1. So the maximum value F can get is 1. And the minimum value of it is 0. Cannot be more than 1, cannot be negative 9. So if we are looking for the median, then we could enforce this function to be 0.5, because that's the meaning of median. Split the data to 2 equal pieces, left and right. If we equate this function to 0.5, then our goal to find the value of x, and the value of x will be the median. If we are looking for the first quartile, then we set this function to 0.25 and we solve for x, and x will be the Q1. And the same idea or the same concept, we are going to use it. If we are looking for Q3, we are going to set this F to 0.75 and we solve for x. But I want you to pay attention to really important piece, that this function defined piecewisely. It means this function equals 0 somewhere, equal to something in another where, equal to something. And the question is, which part of these I have to set it to 0.5 or to 0.25? I will show you how to get that. So yeah, if you put Q2, this must be there, or if you enforce F2 to be 0.5, then this is going to give you the, so we could work both direction. If we put in here, if we know that the value of Q2, then this must be 0.5. Okay. Yeah. F is given, PDF, this one. And what they want. Find the CDF, so we just need to integrate this without limit. B, we need to find the median, Q2, no problem. Let's start with the integral. That's the function, that's the PDF. Integrate the PDF is going to give me capital F. And don't forget, because our integral is not limited, no limit to it, then we need to add a constant. And then from these values, or from understanding the meaning of the area under the curve, the maximum value of it is 1 when x equals, this is coincident. Don't confuse between this one and this one. Don't. In here, we need to put the farthest right value of x. But in this case, it's 1. So if this is 5, for example, then in here you need to say f of 5 equals to 1. And also don't confuse between this 0 and that 0. This is the farthest left value of x. In this case, it's 0. If this one is minus 10, then in here you would say f of minus 10 equals to 0. Okay? Then from these values, we could figure out the constant. How much is it? In this case, equal to 0. Then we need to express our function in here, CDF. So equals to 0 when x less than, because the function is covering nothing to the left of 0. And to the right of 1, function also covering nothing. The only piece is covering the whole area, which is 1, is this. You need to fully understand this. And this is going to help you to get the quartiles. Now, we get the CDF by integrating the PDF. Now we need to find Q2. We know when we substitute Q2 in capital F, this is going to give us 0.5. That's the definition of the median. And here we are going to use letter M instead of X is often used for Q2, just changing values. So this is our function from the previous slide. We enforce it to be 0.5. And X itself is the median in here. So our problem is changed to solving something look like a quadratic equation. If you let t equal to m squared, then this is quadratic equation. It could be solved. So solving for m squared using the quadratic formula, we end up with this result. And then you need to double check that's your median between 0 and 1. If it's beyond 1 or before 0, then you need to check your calculation again. That's that 0.454. Let's see if we have like our capital F is defined in more than an interval. How to equate the function to 0.5 or 0.25? I mean, which part of them we have to equate it? I will explain it in the next. Look on this. Continuous random variable x has cumulative. So I said CDF is given now. Look what we have. CDF, anything before, anything like 1x less than to the left of 1, nothing. Function is covering nothing. Function growing just in this zone and in that zone, or these two intervals. After that, function covering nothing. Really, this is important to understand. Now, if the CDF is given, capital F, so we don't need to integrate, we don't need to do anything, and the question is just how to find, for example, Q1 or Q2, Q3, whatever. We said we set F to 0.25 if we want to calculate Q1. And the question is, which part of F I have to equate it to 0.25? This piece? Obviously wrong. 0 does not equal 0.25. This piece, this one's also wrong. One is not 0.25. But these two pieces could be. Then what should I do? Do it twice, or there is another way to figure it out? Yes. If we are interested in Q1, let's see in next slide. So they ask us to find the IQR. This means we need to find the Q3 and the Q1. Let's start with the Q1. That's our function given. And we need to find Q1, Q3. Yeah, actually nothing in this slide rather than this definition. Go next. Again, when the capital F, CDF, equals to 0.25, it means the input value, x value, is Q1. And when the function equals 0.75, then x is, we use this in mind, and then we could figure out the values of Q1 and Q2 here. So let's start with the Q1. Which piece, again, which piece, this or this, I have to set it to 0.25. We need to try. What do you mean by trying? Substitute values. Look to this interval. Substitute 1, for example. If we put 1 in here, we get 0. Then we cover nothing. Substitute 2. If we put 2, the function is going to equal to 0.20. And 0.20 is less than 25. Then this one cannot equated, I mean this function cannot be equated to 0.25. You could try it. Like it's a good idea to try it. Then 0.25 has to come from this piece. So 0.20 plus something. Then we need to equate this part to 0.25 to find Q1. I already explained this. So we are going to go to the second part. And here we go. That's the second part. X squared over 10. So now we put the right notation instead of x. We know this is not any x is going to give us the 0.25. This is Q1. So Q1 over 10 squared minus q1 over 5 plus 1 over 5. Equate this to 0. And the question now is solve for q1. Then we'll find two values, since this is quadratic, two values of q1. One of the values is negative, and negative, it really does not belong to our definition. So we are going to ignore this value. But the second one, 222, fall within this interval. So q1 equals to 222. Okay, select the value that is the appropriate. Yeah, that's, we did see the negative does not belong. Okay, now we need to find q cube. So q3, third quarter. We set no more options in here. We don't need to check. That's the only option we have, because q1 within this, q3 must be in here, because nothing beyond. But let's say if this function is like one more piece in here, then what do we have to do? We need to check this 4, put it in here, and we see, does this 4 is going to give us something more or less than 0.75? If it's less, then we go to the next. If it's more, then that's the right place. As I said, in this case, we have no more option rather than this. Equate this function to 0.75 and change this notation. Instead of x, call it x cubed. Direct substitution, solve for q, and then also quadratic equation, two different values. -1 is going to be omitted because it's not falling within our limit. So the right answer is this. So we get q3, we get q1 from the previous slide. Then we could calculate the IQR as q3 minus q1. And yeah, most likely that's the only thing I want you to pay attention to, know which piece you have to equate it to 25.25 or 0.75. Nothing in here. Just double check which value we have to choose. Choose the positive one because it matches our limit. And then we get the IQ. To summarize what we did, if you integrate the distribution function, which kind of function is this? The x-axis is the variable itself, and y-axis is a function give you the probability of finding that x. So if we integrate from -infinity to +infinity, we need to set this integral to 1. If this integral does not equal to 1, this already been solved in the previous lecture. We need to multiply this function by some constant, and that constant is going to make this 1. The kind of, we call it normalization. How to calculate the mean or expectation value, sometimes they call it. We just need to integrate the product of the variable itself multiplied by the PDF. And the limit, we did see it, it says in here -infinity plus infinity, but you will see it in most of the, actually in all of the seminar problem is just finite numbers. But it's a piecewise, so you need to do it couple of times to go over all the intervals. How to get the variance? The variance is like expectation value of x squared instead of x. And then you need to subtract mu squared, that's the mean square. This one, cumulative distribution function. This one is here, that's the really nice information. Maximum value of this function is 1. The minimum value is 0. And if f of x equals to 0.5, then this x is q2. And if f of x equals to 0.25, then this x is q1, and so on. How to get probability from like specific cases when x greater or less or whatever. The only thing you need to perform the integral and caring about, since in here x is less than a specific value of x, then we need to integrate from the negative infinity and stop at that value. Median. Median when f, yeah, I already talked about these three from this. And we more formula, I think the learning outcome in here, yeah, that's it, we done. We find the mean, variance of the continuous random variables. Also, we find the mode, median, and the quartiles of the continuous random variables. We'll go over some problems with the seminars, and I wish everything will be cool. Take care. Bye.